Hello everyone, welcome to UNC virtual class, and today's topic I am going to describe about the concept of computer graphics field, that's your Bezier curve. As you know, the term curve to be inherits when any types of straight lines that to be deviates in any positions, in this case the curve to be created. Okay, so here is an outlines which I will discuss on today's class one by one. First I will describe about the concept of Bezier curve, then after I will describe what are the features and properties which is to be used for creating this given Bezier curve, then after lastly I will describe the mathematical derivations by using which functions the given Bezier curves to be created. So now to start our initial concept of the given Bezier curve, here the Bezier curve may be defined as Bezier curve is a parametric curve defined by a set of control points. That means the curve is a one type of parametric curve and that to be consisting number of control points through which that to be interconnected and providing one curve structures. And in this case compulsory there are two endpoints that to be given in between your given curves. That means 2 points are ends of the curve and other points are whatever the intermediate points that to be determine the shape of the curve structures. That means the term Bezier curves means it is one type of concept, it is one type of technique through which different types of curve very smoothly we have to design it. And by using this given Bezier curves, if the user to be needed for drawing any types of polygon structures, that will be very easily possible by using this concept. That means here the Bezier curve to be defining the terms of polygons, and in this case whenever we have to draw any types of polygons, here that to be defining the two end coordinate points and another all over the intermediate coordinate points whatever to be present in between your two end coordinate points, that to be normally defines the shape of the given Bezier curve structures. And this curve to be very highly designed through which the user to be very easily understand how the curve to be executed one after another point connections. Okay, so now goes to our next concept, that's your Bezier curve examples. That means here one curve that's to be described by consisting 4 end coordinate points. Here is the coordinate points, that's your B2, that's your B0, that's your B1 and that's your B3. Okay, that means in this case the Bezier curve to be contains 4 control points, and here in between your 4 control points there are 2 end coordinate points, that's one is that's your B0 and another one is the B3. Okay, here is the starting coordinate points, here is the ending curve coordinate points, but in between the given intermediate coordinate points of the given curve, that's your one is B1 and another one is the B2. And by using this given intermediate coordinate points, easily the user to be identified which types of structures of the given curves. Okay, now goes to our next concept, what are the properties and features we have to use in case of Bezier curve. By default whenever the Bezier curve we have to draw, in this case every Bezier curve is always contained within a polygon called a convex hull of its control points. That means here is one curve that will be consisting of 4 control points, and in between your 4 control points, when the one control points like your B0 that to be interconnected with B1, here one convex hull polygons to be created. Normally as you know, the convex polygon and concave polygons to be created whenever the user to be draw any types of polygon figures. So what do you mean by convex polygons and concave polygons? In case of convex polygons, if any types of polygons to be created and its interior angle value that to be less than to 180 degree, in this case whatever the polygon structures to be created, that's to be convex polygons. But if the interior angle of the given polygon structures, any one angle that to be greater than 180 degree, in this case that to be created one type of concave polygons. But when we have to use in case of Bezier curve, in this case always what are the intermediate coordinate points that to be connected with the control points, here the 2 control points to be created one angle value that to be compulsory less than to 180 degree. So that here the first properties to be derives that here all over the intermediate pixel points to be created one convex polygons. Okay, Now goes to our second properties. The second property is here, that's your Bezier curve generally follows the shape of its defining polygons. That means always the Bezier curve to be follows how the shape structures to be defining. As here the shape structures to be easily identified by using your intermediate pixel points, so that here the Bezier curve to be follows the shape of defining polygons. And here the first and last points of the curve are coincident with the first and last point of the defining given polygons. Okay. Now goes to our next properties. Here the next property is the degree of the polynomial defining the curve segment is 1 less than the total number of control points. That means here the degree to be calculates number of control points minus 1. That means as here in previous pictures there have contains 4 control points. So if in this case we have to calculate the degree of this given polygon structures, it will be defines the degree equal to 4 control points minus 1. That means compulsory the degree to be calculated number of control points that to be less than 1. That means here the degree is 3. Okay. So now goes to our next properties. That's your the order of the polynomial defining the curve segment is equal to the total number of control points. That means when we have to express all over the graphical elements through the help of mathematical functions, in this case we have to use the polynomial parametric equations. Okay. So if the programmers to be required for finding the order of the given curve structures, in this case whatever the control points to be available for drawing the given polygons, here the total number of control points equal to that's your orders. That means here we check if this figures to be contains 4 control points. That means here the order is 4 as it contains 4 intermediate, as it contains 4 control points. But whenever we have to calculate the degree, here the degree equal to number of control point minus 1. That means degree equal to 3, order equal to 4. Okay. Now goes to our next properties. That's your Bezier curve exhibits the variation diminishing properties. That means the curve do not oscillate about any straight line more often than the defining polygons. That means in this case whenever the Bezier curves to be created, that to be diminishing the properties. Whenever any types of straight lines that to be deviates for creating one Bezier curves. Okay. Now goes to our next concept, that's your mathematical derivation of the given Bezier curve and as well as the cubic Bezier curve. That means as you very well knew that the Bezier curve to be used for drawing any smooth curve by using very little amount of time quantum. That means by consuming very less time, how we have to smoothly creating one type of curve without using any types of mathematical functions. In case of Bezier curves, that to be provides for defining the given polygons by using number of properties. First of all, it to be provides the two end coordinate points of the given curve and the structure of the given polygons to be easily carried out by using the intermediate pixel points. And in this case, if it requires for calculating all over the curve intermediate pixel points through the polynomial structures, that to be also possible. That means in case of Bezier curve, that to be solved by using some polynomial parametric equations, as here it to be defining the polygon structures. Okay. So now to check how the mathematical derivations to be provides for finding the all over the intermediate pixel points in case of Bezier curve to draw the curve in smooth ways. So now to check all over the mathematical derivation concept. Now to check how to find all over the control points of the given Bezier curve by using parametric equation. So here is the parametric equation of the given equation of the Bezier curve. As it to be follows by using the linear equations. So here the linear equation format of the parametric equation in case of Bezier curve, that's your P of t equal to summation over I equal to 0 to n B of I j of n I of t. That means here the Pt defines the parametric equation of the Bezier curve for finding the all over the intermediate control points of this given curve. And here the BI, that means the Bezier curve of the time quantums, that to be belongs from time 0 to 1. Okay, 0 to 1. And the BI describes the number of n coordinate points. Number of n coordinate points. Okay, n coordinate points. N coordinate points. That means suppose here is the curve, and this curve to be contains two n coordinate points. One is the P0 and another one is the suppose P1. Okay, but if we have to calculate the intermediate pixel points by using your Bezier curve parametric equations, here P2 and P3 to be describes the intermediate curve pixel points, through which we have to easily know that the shape of the given polygon structures. Okay, so in this case the BI indicates the n coordinate pixel points of the given curves. Okay, that's your P0 and P1, and the JNI components to be given all over the control points of the given curve. Okay, that's your general parametric equation of the Bezier curve. Now to take one examples by using the given cubic Bezier curve equations. As you know, the cubic Bezier curves to be normally consisting of 4 control points. That means when the degree is 3. So here is the structures that to be defines the cubic Bezier curve structures. That means as here that to be contains 4 control points like your P0, P1, P2, P3. P0, P1 that's your 2 n coordinate points, control points, and P2, P3 describes the shape of the given curve structures. Okay, if this given cubic Bezier curves to be required for finding all over the intermediate coordinate points, in this case the Bezier curve equations to be calculated by using polynomial equation. And here is the polynomial equation is that's your P of t equal to that's your 1 minus euro whole cube, that's your P0. That means as here the coordinate points to be starting P0, then after plus as here that to be expressed through the help of polynomial equations. So then the next intermediate coordinate pixel points, that's your P2, that's your P2 is to 1 minus u square that to be multiplied with 3u. Then after P3 that to be multiplied with 1 minus u 3u square. Then after plus P4 that's your P1 as here that to be ended with P1, so that's your P1 of that's your UQ. Okay, so that's your general formula for finding the given polynomial equation, the given Bezier curves. Okay, if we have to elaborate this, that's your P0 1 minus u whole cube, that means 1q minus 3a square v, 3a square v, that means minus 3u plus 3a b square, that means 3u square, then plus uq. Okay, as here that will be defining the 1a minus b whole cube, so that here the second value that's your minus yq. Then after we have to finding the next expression, that's your a minus b whole square, 1 minus 2u plus v square, that's your u square, that to be multiplied with 3u. Then next value P3, that's your 3u square minus 3uq, then plus P1uq. Okay, if we have to solve this expression by using your parametric equations, now to check, that's your 1 minus 3u plus 3u square minus uq, then plus P2 the 3u value that to be multiplied with this given expressions, that's your 3u minus 6u square, then plus 3u cube plus whatever the expression that to be constant, that means P3 3u square minus 3u cube plus P1u cube. Okay, if this given expressions we have to convert it on the format of parametric, here the parametric equations that will be consisting of 4 control points. That's your u cube, u square, u1 and u to the power 0. So first to input this given expression by using 4 control points. Here the value of u cube, that's your 1. Okay, then after that we have to check u square value, that's your positive 3, and the next u to the power 1, that means here is the constant, that's your minus 3, and the next value u to the power 0, that means the constant value, that's your 1. That means here first u cube that to be contains the negative value, as here it to be contains minus u cube, then after that it contains 3, then minus 3, then positive 1. Okay, so now to check the next linear equation value of the control points P2. Okay, so I let just by sense take bole jo bala minus 1 3 minus 3 1 ठीक है. So now to check the next constants in this by using these equations, that's your u cube, that means that's your value is 3. Okay, that's your value is 3. U square, that means here the u square coefficient value, that's your minus 6, and the next u to the power 1, that means here is constant value is 3, and as here there is no constant value u to the power 0, so the value is 0. Okay, so now to check the next constant's value, that's your p of 3, that's your, here we check first the q elements, that's your present minus 3, then the square elements, that's your positive 3, as here there is no polynomial equation of the power 1 to be available, so that the value is 0, and also in case of u to the power 0. And lastly we have to check, here it only contains the last coordinate points only contains the cubic polynomial equation data value, that's your value is 1, and other have to be absent, that means the value is 0. So here is the expressions of the given parametric equation of the Bezier cubic curve, through which we have to easily calculate all over the intermediate pixel points. So by using this given Bezier curve parametric equations, the normal equations through which we have to finding all over the intermediate pixel points, that's your p of t equal to u dot m of v dot g of v, and the m of v to be specifies all over the intermediate pixel points of the given Bezier curve. Okay, so whenever we have to require for finding all over the intermediate pixel points for finding the given shape of the Bezier curve, in this case we have to calculate all over the intermediate pixel points by using this given formula. That means as here that to be contains 4 control points, so that in this case the degree is 3. That means we have to starting the control points that should from P02 up to P3. Okay, but whenever any types of curve that to be contains 4 pixel points or 4 that to be contains 5 control points, that means here the degree is 4. That means here the degree of the u coordinate value, controlling value, that's your u to the power 4. Okay. So for today's class we have to learn about the Bezier curve, that means how we have to draw the curve in smooth way by using some parametric equations. That means by using some polynomial equation. For smoothly how we have to designing some convex polygon structures through the some parametric equations. In this case we have to use the Bezier curve equations. Okay, that means in simply way how by using 2 end coordinate points we have to designing different types of curve structures. That all over the things we have to learn by using different properties and features of the given curve. Okay, so for today's class that's all. If any conflict or confuse in your mind, then you can ask me with the help of comment box. That's all. Thanking you.